Hello everyone, it's 1 p.m. Eastern Time, and that means it's time once again to begin another CoCoRaHS Weather Talk webinar. Thanks for joining us today. I'm your host, Henry Regis. Behind the scenes today, running our technical side of the program, are Zach Schwalbe and Noah Newman, and joining me is my colleague and CoCoRaHS founder, Nolan Duskin. We're coming to you live from the Colorado Climate Center in a very, very windy Fort Collins, Colorado. Boy, that wind is really blowing this morning. For those of you who are unable to join us for our live broadcast, we'll be recording this one for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, today's webinar goes on talking about the daily life of a climatologist, what one is and what they do from day to day. We're excited to have with us from the home of the Wolfpack, and that's my alma mater, North Carolina State University, Ryan Boyles. He's the North Carolina State Climatologist. As a state climatologist, Ryan is the chief scientist with responsibilities to develop and promote the office's climate services for extension, research, and education of applied meteorology and climatology. And Ryan, welcome. It's a pleasure to have you with us today. How's the weather down there? I think Ryan's there. We're getting he might be on mute.
Oh, there we go. Now I got
Oh, there you go. Great to have you with us.
Thanks for inviting me. A pleasure to be here today to talk with everyone. Let me get the screen set up here so that everyone can see. And Henry, just confirm when everyone can see the. Is that showing up right with 2 slides or 1 slide?
That's got the. We need to go to the other. We're seeing your. There we go. That's it.
Okay. Thank you very much.
Excellent. Oh, take it away, Ryan. There you go.
Well, thanks. I'm sorry to hear it's so windy in Fort Collins. Certainly in Raleigh right now, it's a lovely spring-like day. We had 70 degrees yesterday here. Of course, there's still snow on the ground from snowpocalypse that came through last week. Many of you may have seen on a lot of the news the shutdown that a good bit of snow last week caused the city of Raleigh. Came through in the midday and caused a lot of people to get shut down. But today I'm going to talk to you a little bit about what's it like to be a climatologist. I'm a state climatologist, so I'm going to focus a little bit more on that specific aspects of my life. I'm here in Raleigh, North Carolina at NC State University. I've got an extension appointment with the Department of Marine Earth and Atmospheric Sciences. And like many of you, I am cuckoo for CoCoRaHS. I love CoCoRaHS. I was helping to get it started here in North Carolina a few years ago, and now, well, frankly, much more able people than I are running it and doing a great job. I'm sure Henry will promote this later, but I'm going to go ahead and put a plug in. It's coming up on March soon. That means March Madness for CoCoRaHS. So tell your friends, get them signed up, especially if they live in North Carolina. We want to get that CoCoRaHS cut back to North Carolina. So, a climatologist, what is it? What do we do? So this is your typical HVAC system, right? Your air conditioners, your compressors, heating and cooling units, and this is what a climate control technician looks like. And this is not what I do. We still get calls actually in my office from people who are telling us that their air conditioning on campus is broken and can we come and fix it? And I have to sort of chuckle and say, you've got the wrong number, but we can tell you what it's likely, how likely you're going to suffer for this time of the year, especially if it's in the middle of the summer down here in North Carolina. What we do as climatologists is study climate. And specifically, we study the Earth's climate system. Now, there are other folks who study the climate system of other planets, but generally, when you talk about a climatologist, you're talking about someone who's studying the Earth's climate system. Many of us are trained in the broader atmospheric sciences, including weather dynamics and even short-term forecasting. But I don't study weather so much, and I'll be the first to tell you I have no clue what tomorrow's forecast is. I will probably look at it tonight just to see what the weather forecast is for tomorrow, so I know how to put what kind of clothes to put the kids in. I think there's a chance of rain, but I'm not entirely sure. What I spend more time thinking about is shifts in probabilities for a specific type of weather pattern or what next season is going to be. And I'll talk about a little bit of the things later on here that get us excited, things that I spend a lot of time thinking about and reading about. But in general, I'm focused on what's happening on longer time scales, not what's happening day to day. Now, sometimes folks call us generally climate scientists. Now, that's not always taken as a polite term, especially since a lot of, at least historically, there are a lot of biologists and ecologists and engineers who might use climate data to study their discipline, and sometimes they call themselves climate scientists. But I like that term, climatologist, and it means that we're studying the physical climate system, because most of us are actually physics. physicists. We're trained as atmospheric physicists. And so we primarily look at the physics of the Earth system. And what I mean by that is the exchange of heat and energy in the climate. How does the atmosphere interact with the land? How does it interact with oceans? How do they change over time, day to day, season to season, decade to decade? There are a lot of different types of focuses within the world of climatology. There are folks who focus on climate dynamics. There may be others that are modelers that focus on modeling the climate system. There are others that focus on observation and historical climate. Others who focus on statistical methods, physical geography. Others who do radiation balance, energy exchange, land surface processing. It goes on and on. There's lots of different subsets. I myself am what most folks would consider an applied climatologist. And by that I mean that I often try to walk in a couple different worlds at any given time. I have training in the physics of the atmosphere, but I try to apply that to agriculture and water resource management. So a lot of the folks that I meet with on any given day are scientists from these other sectors. So whether they're civil engineers looking at civil infrastructure and impacts to roads and sewer and water systems, or they may be agricultural scientists that are interested in pest management and predicting fungal disease outbreaks, or they may be water resource managers doing planning for new reservoir design, or looking at how much water gets used across an entire basin, so they make sure that they're planning for enough water supply over the long term. And even among applied climatologists, there's a subset of folks called the state climatologist, and that's what I do. And we tend to be applied climatologists, but in addition to the science side of things, we're also very interested in the service side of things. So state climatologists tend to focus on climate services. And what do we mean by that? Well, translating and delivering climate science and climate data. A lot of us are really interested in climate data, but also making sure that people can use it effectively. So a lot of what we do is sort of science translation. How do we take some of these complexities of the science and actually extend it out beyond the university, beyond the scientific papers that we contribute to and read, and help get it out to folks who are making decisions? So a lot of what we do is under a decision context. I'm fortunate that as a state climatologist, I'm at a state university, and about 2/3 of the state climatologists are at state universities. About another third are actually in state agencies. I say I'm fortunate because I get a lot of freedom. I get a lot of flexibility to go out and kind of do the things that I'm excited about. And my dean says, every year you're doing a great job, keep it up. In state agencies, they have often a slightly different focus. A lot of it's very similar. In exchange for maybe not having to do some of the more bureaucratic things that they have to do in state agencies, and may not necessarily have as much flexibility and freedom I have, but they tend to have fixed budgets, and of course those of us in universities, we're chasing grant money just like everyone else, so we're always having to go out and write grants and chase money as well. But one of the things that keeps us all sort of shared in our vision as state climatologists is focusing on that science and service delivery. We also tend to focus as state climatologists, on a fairly limited geography. I mean, we're aware of what's going on globally, but really we're pretty focused on what's going on in our state. And so this is sort of my typical view of the climate system right now. There's a world and there's the U.S., but really North Carolina is the most important thing, and it stands out. Everything else is sort of hazy and in the background. I know that there's weather going on in Virginia, and I hear about big events up in New England, but they just sort of passing news. I don't really get too excited about it. But when it starts to affect my state, then I get excited. That's when the emergency managers start calling. That's when state agencies start calling, wanting information. That's when we really beef up our interactions with Weather Service, whether there's an event that's coming through. Mostly not to try and do a better forecast of it, but to try and translate those forecasts into impacts. So what I want to talk a little bit about is sort of what I do on a typical day. And I'm going to break them down into three broad areas here and go through some examples. Most of my life being at an academic institution is working with students and other scientists. I'm going to talk about some of the data things that we get excited about, maybe even obsessed with. And then a lot of what we do is focused on communication of that data and science. I'm really fortunate. I get to work with a pretty big group with some really wonderful people, and they really are the success of the program. It's a lot of young people who keep me excited and keep me energized, and also keep me involved in the latest gossip of what's going on the evening TV soaps, because I don't have a chance to really read them. and we're pretty fortunate that we've got a lot of support from our university for such a big group. So this is our group as of last summer, and sort of one of the sad things, though, of course, is that students always come and go, and you never really get a chance to get to know people more than just over a few years as the students migrate on. We're fortunate also to have some really talented staff who spend a lot of time manipulating the data, working with the data, talking to clients, and helping them translate the climate data and climate science into applications and decisions that they need. But I should emphasize that most state climate offices don't have programs that are this large. They're still incredibly diligent and very valuable people, but a lot of programs only have a handful of people, and they're able to do tremendous work with just a handful of resources that they have. Now, in addition to talking to students every day and talking to people every day, I tend to like to look at data every day. And we look at all kinds of data. I like looking at time series of extreme events, whether it's talking about drought or floods or temperatures or precipitation, cloud cover, radiation. I want to see what is it going on over history. So a lot of the data that we look at is either tabular form, we like looking at graphs, but we like to look at it over long periods of time. We like looking at projections, we like looking at maps, especially pretty maps. I like making and looking at pretty maps that really help to convey what's going to happen now, what's happened in the past, what's going to happen in the future. We look at probabilities and distributions of data. How does this rank in terms of the longer-term history of extreme events? Is it close to normal? Is it way outside normal? Is it a record event? And then we look at exciting things like multi-model ensemble evaluations, which to most folks is just gobbledygook. But what you see is different metrics of correlation and skill for a lot of different models. In this case, ones that do well, ones that don't do well. We look at more maps, and we look at more data, and we look at spaghetti charts, and we look at diagrams that show error and probability, and it's just lots and lots of data. All of it usually climate and atmospheric data that we try to synthesize into something that really tries to ultimately take current conditions and future conditions and put those in terms of a historical context that people can relate to. So in addition to looking at the data and the data products, we also spend a lot of time collecting data. So whether it's taking advantage of the CoCoRaHS network or looking at more advanced sensors that certainly don't have the wonderful spatial density that CoCoRaHS has. In some cases, we actually deploy our own data, and we collect our own sensors, or make our own sensors and collect our own data from around the nation. So we're thinking about focused on what's happened in history. We're thinking about current conditions. We also get really interested in records and extremes. How does the current variability that we've had, it seems like here in the southeast we've had a lot of warm followed by cold followed by warm. How does that compare? Those are the kinds of questions we're asking on any given day. And then we go and we dig up the data and we analyze it to try and answer those questions. And so in addition to looking at the historical data, we're collecting new data through our own mesonets. What the picture is up there is one of our scientists that's working on a high elevation site near Mount Pisgah in western North Carolina. It's about 5,000 feet up. I know nothing compared to the Rockies, but for us that's a pretty tall mountain looking down out into the Yadkin River Valley there. And then, of course, once we have the data, we mess with statistics, and we're always looking for the best set of statistics to try and compare everything, because the analysis of that historical data is what helps give us some context as to what we can expect on any given day. So beyond the data, we also start getting into communication. How do we talk about the science? How do we talk about the data and convey it to others in such a way that it can be useful to them? We aren't as a very focused disciplinary science. We're very applied, and so cross-disciplinary. We spend a lot of time talking with other scientists about the kind of things that they're interested in, but also some of the things that they may not be aware of that may be there to serve them. So we synthesize a lot of data together. So where we're combining rainfall and stream flow, we're looking at model output and how it varies over space and time. How do we choose the right color scheme to convey that to a user? How do we convey things like risk? How do we convey probabilities to users? How do we look at how current conditions compare to past events and the risk that might be associated with it? How do we relate what's happening with things like current conditions in the seasonal forecast to impacts to agriculture and crop yields, diseases that may occur? We look at hurricane frequencies and what does that mean for coastal communities? And we spend a lot of time communicating it to teachers and other folks. How do you convey complex science into terms that other folks can use? So maybe we talk about humidity and frost and dew point, and we use those in terms that maybe an agricultural community would use. We use examples that relate to them. But then we also do communication to Girl Scout groups that come through and want to learn about weather and climate and how we measure it. So that's my giant rear end talking to a bunch of Girl Scouts. And this is probably pretty typical of what a lot of state climatologists do, synthesizing a lot of different data, communicating that to a variety of different audiences. They try and be that sort of initial focal point for anyone and everyone that has questions about their state's weather and climate. Then beyond talking about what's happened and what's happening now, we start asking the why questions. Why is it so hot and cold? Why is it wet and dry? How does this year compare? And then why did it happen? Will it happen again? What's the likelihood of this happening again? But not so much on what's happening for the short-term forecast. We also start getting into, okay, this snow event came through, how does that compare? But also what's happening next season? What happened last winter? Why did it happen? What might happen in the longer term? And, you know, more than about 15, 20 years ago, we didn't even talk about climate change. But nowadays, we spend our time also talking to folks about climate change and what that means for our state. What does that mean for the risks that we may experience in the future, and how confident are we, and how might you plan to try and mitigate some of those risks that are out there? So a lot of what we do is thinking about terms of and connecting with the social scientists on how to communicate some of these things so that they're better understood by the folks that are actually trying to make those decisions. So what I think about that is it's a lot of science translation, taking the science that we think we understand with all the caveats that come with it, and turning that into some terms and information that's more useful to others. And quite often we rely on technology and computers to do that. So a lot of folks sit behind a computer these days, but certainly with the terabytes of data that we have at our fingertips and the petabytes of data that are in the National Archives, we spend a lot of time trying to manipulate these massive data sets to visualize it in such a way that it really does connect to the folks that are trying to make decisions, and then helping them use the technology or build the technology so that it enables their decision support. So in addition to sort of that communication side of things, because I'm at an academic institution, a lot of what I do is focused on client-driven research. So there are research questions that often come to me, and I have some myself, but it's not exploring questions of climate science for science purposes necessarily. We have some of those questions too. But as applied climatologists, a lot of our research efforts are connected to questions from other disciplines. What are the weather and climate impacts to agricultural productivity? What are the weather and climate impacts to water resource management? What are the weather and climate impacts to our energy and road infrastructure? And so I tend to think of the state climatologist, you know, when we're talking to other folks, it's kind of like that 80s TV show. You know, if you have a problem and no one else can help you, and if you can find them, maybe you can hire a state climatologist. So a lot of us are out there, folks sometimes they do know about us, sometimes they don't know about us, but we often get the calls from someone who said, I'm so glad I found you. I didn't know there was such a thing as a state climatologist. These are my questions. Can you help me? And quite often we can help them, and it's really a great resource. But of course, none of us are big and mean like B.A. Baracus, and unfortunately none of us are as handsome as Face Man. But there are some state climatologists out there, and I would have to say that I'm, of course, the most handsome of us all, and I'm the one who gets all the ladies, of course. But there are others out there, including some of the famous faces that you may recognize here. Nolan Duskin being, of course, one of our fearless leaders. But there are many others that are out there, and all of us have a shared goal of trying to really take the climate science and extend it down to folks that use it. So we tend to be very multidisciplinary and cross-disciplinary researchers working in climate applications to a lot of other folks, be that water or agriculture or human environmental health. And a lot of these scientists are working in some sort of decision context. What are the decisions that people are trying to make? What are the complexities that are out there that they have to deal with? And then how can we use our understanding of climate information, climate science to help them address those decisions? So what I wanted to sort of move on to now is give an overview of some of the things that really get applied climatologists, and in particular state climatologists, excited. And you're probably going to guess what some of these are based on where I've been talking so far. But first, data. Now, we love sensors and we love collecting data. We argue about whether this data sensor is appropriate, what's the proper height to record this sensor. We argue whether or not that sensor has the proper exposure to be truly representative. We're always getting together to meet about what's the best set of ways to duplicate sensors, what's the best set of ways to find that new sensor that's going to solve all of our frozen precipitation problems. And then when we get excited about more data, where's the next data source going to come from? How do we get more data? We always want more and more data. But we also get excited about really extreme events, floods, droughts, hurricanes. Of course, in the southeast, we're really excited when hurricane season rolls through, but ice storms, tornadoes. We get excited about severe weather events just like any atmospheric scientist, even though we don't spend our day-to-day lives studying the dynamics of a specific ice storm or of a specific hurricane. We're very much excited in extreme events, and especially the historical frequency of these extreme events and the impacts of those extreme events to our society. We love El Nino. We love El Nino so much we have a song about El Nino. And when the state climatologists get together, if there's an El Nino event, you know we're going to be singing the El Nino song. Good luck to anyone who can get a recorded copy of it. I've been digging around for one for years and still can't find one. But because we're so interested in seasonal forecasts and things like El Nino and La Nina drive those seasonal forecasts, we really pay attention to the El Nino discussions that are going on. It looks like the models are converging. We may start to see a hint of El Nino starting to emerge in the spring and into the summer. If that happens, that has big implications for what happens in the tropical storm season. That has big implications in the southeast for what our winter is going to be like next year. So anytime there's a discussion of El Nino and La Nina, we're out there, we're getting excited. We also love drought. We are some drought-loving people. We love drought so much we get together every week. There are hundreds of emails every week among applied climatologists, state climatologists, talking about drought. How severe is it in my area? How does that compare to others? Where are the impacts? How does it compare over the past 6 months, the past 12 months? So that we can improve what gets depicted on any given week's drought monitor. There's so many emails that come across, I can't keep up with them all. And in North Carolina, I feel like for the past decade, every Tuesday afternoon we get together, we talk about drought in North Carolina. We share that with all the other folks around the nation. It's tough to find a group more than the state climatologist and the broader applied climate community that loves drought more than we do. But there are some things that we don't love, some things that really bring us down. And I'll talk about a few of those just to give some context. But in general, the media tends to bring us down. And there's a few things about the media that tends to bring us down because a lot of us work with the media. Now, some of us work with the media more than others, or we have a few of my colleagues in other states that are really superstars with the media. Dave Robinson, man, in New Jersey, he is the media king. If it's dealing with weather in New Jersey, Dave Robinson's out there. But some things about the media really frustrate us. And one of the things is saying that any given event is due to global warming. It happens anytime an extreme event comes through. A reporter almost always seems to call up and says, is this due to global warming? And we have to sort of explain to them that, well, climate change occurs over long periods of time. You can't really attribute any single event entirely to climate change, but there are some things that we can say that might suggest this is typical of what we would expect in the future. We've had this conversation with reporters, whether they're broadcasters or written reporters. I feel like for a decade we have this conversation all the time, and it gets frustrating after a while. We don't feel like we're really effectively communicating as well to the broader media as well as we should. And so these are some of the things that get us frustrated. The other thing with the media is, sometimes we'll invest 3 and 4 hours talking to them about some really interesting, complex stuff, and we think that they have it, and then it gets boiled down to a 5-second clip on the evening news or just a single sentence. And all of that complexity gets lost and sometimes doesn't get translated properly. So that can be frustrating. That gets me down when I spend a lot of time and I think the reporter really understands what's going on, and then for a variety of reasons it doesn't come out that way. And that connects to, I think, a broader misunderstanding of what we do as part of science and the scientific method in trying to study things as scientists. The media doesn't quite get that, and I think we've had a real loss of, in particular, science reporters that were pretty pervasive around the nation and really are now isolated to the really good science reporters are really only at a few major outlets. So the other thing that we have is kind of a love-hate relationship with data. We love data, and yet we're always frustrated by the data because there's never enough of what we want, but at the same time there's always so much out there that we have a hard time managing it all and synthesizing through it quickly in such a way that we can be really responsive to all the folks that are asking these questions. So it's just sort of a strange dichotomy here with our love-hate relationship with data. But I would say, in the most part, we love data much more than we love the media. But certainly we need more data, and we need the media just as much as we need the data sometimes to help us communicate what's going on in the weather and climate system back out to other folks. So that's sort of a brief overview of what it's like to be a state climatologist. I wanted to make sure we had plenty of time today for questions so that I could be responsive to some of your needs. We are applied scientists. we focus mostly on conveying weather and climate science and weather and climate data to other disciplines and other folks that are impacted by it. But many of us also do our own research and are interested in how climate science can be advanced, especially under the decision needs for a lot of the clients that are out there. If you ever have questions or want to talk to a climatologist, feel free to give us a call. You can follow us on Twitter. If you really care about weather and climate in North Carolina, if you're in another state, we probably don't do a whole lot to meet your needs, but you've got a state climatologist who's a better resource for you. But if you're just curious about the career, feel free to contact me or give me a call, I hope you're out there spreading the gospel of CoCoRaHS. So with that, I'll turn it back over to Henry and Nolan and Zach and Noah, and we'll start taking some questions.
Thanks, Ryan. Really appreciate your enlightening us on what a climatologist does. And we do have with us today our state climatologist here in Colorado, Nolan Duskin. And so, folks, if you want to type in any questions for the both of them, go ahead and do so. And Nolan, are you there?
Clearing my throat. Yes, I am here, and can I have the first question to ask Ryan?
Sure, go right ahead. Are you guys going to sing the song for us, the El Nino song, a duet maybe?
I think another day maybe.
Okay, we'll record that.
We have to have at least 3.
Gotcha.
I'm just curious. I have a pretty good handle on our all-time records for snowfall, rainfall, etc. In fact, Colorado just set our new one-day rainfall record just in our flood back in September. But you folks can get some incredible rains there. Can you give us an idea of what some of your all-time record rainfalls have been?
Sure. Our all-time 24-hour rainfall was from back-to-back hurricanes that rolled through in July of 1916. It flooded the entire town of Asheville. We had 22.22 inches in 24 hours in 1916. And that actually stood as the national 24-hour rainfall record for several decades. But that still stands as the statewide record for 24-hour rainfall in North Carolina. The snowfall records are a little tougher. We don't get as much snow here in North Carolina, and so we haven't done, frankly, as good a job recording it over the years as I think states that are more accustomed to getting snowfall. But some of the sites in western North Carolina in particular, Mount Mitchell stands out as one of the areas that typically gets lots and lots of snowfall. And so and they're one of the areas that get probably the most extreme snowfall events. And so we have some pretty high, maybe even outrageous numbers for some locations there at Mount Mitchell. So we have some records. I'm not sure if they're as accurate as I might like them to be, especially with the snowfall. But we do know that, for example, Mount Mitchell has gotten over 120 inches in some seasons. The greatest 24-hour snowfall was 60 inches in April of 1987. The other thing, of course, in terms of annual records, we have a tremendous contrast here because of some of the rain shadows here, so that our wettest location has gotten in excess of 130 inches of liquid rainfall in a single year, and not far away is our driest location that averages less than 30 inches a year. So it's quite an interesting contrast there in a relatively humid climate.
And how did 2013? You had a lot of wet weather. How did 2013 stack up with some of your wettest years in history?
2013 actually wasn't that wet. It started off very wet in the first half of the year, but then we really dried out in the last 3 or 4 months. So the 2013 in western North Carolina went down as part of one of the wettest years, but in central and eastern North Carolina was not that wet at all. In fact, it wasn't even in the top 30. And so we have with such a long state going from west to east, you can have really dramatic differences. And I think back in particular to what happened with Hurricane Floyd in September of 1999. We had quite dry drought conditions in western North Carolina. Hurricane Floyd came through and put 20 inches of rain in 3 days, and they were underwater. So across about 200 miles, you went from very dry conditions, sort of D3 conditions, all the way out to record flooding events over about 200 miles.
Okay, guys, we got some questions coming in. So let's take some of those, and then we can go back and forth with you guys here. Actually, Alex had written in a question. Alex, it fell off our screen, so if you could retype that one, we'll be glad to answer it. Here's one here from Natalie. Wants to know, how is global climate change incorporated into state climatology?
So most state climatologists are aware and follow the scientific literature that goes on with global climate dynamics, and many of us certainly try and stay on top of the literature. I know, speaking for myself, I try to. There's a lot of literature out there to try and stay on top of. But what we really try and do is focus on what those impacts are going to be to our states and to the citizens in our state. So what we tend to do is not so much follow what's happening with global projections, but try and look at more of the regional projections and look at those shifts in probabilities, what's going to be the shift in the number of hot days, shifts in the number of cold days. But as a coastal state, we're also very interested here, and this isn't my area of expertise, but very interested in what's going to happen with changes in sea level rise and how that might happen. But a lot of it comes down to what are the decision contexts that people have. And there are not a whole lot of decisions out there that people really make on climate change timescales. If you're going to build a bridge out over an inlet along the coastal zone, okay, well that's something you're going to want that bridge to be there for 50 to 100 years. You probably want to think about climate and climate change over the lifespan of that bridge. But for a lot of what our clients are doing, it's what crops to plant next year. How do we manage our reservoir this coming season? Those aren't really questions they're asking that have a whole lot of climate change context to it. So the ones where there is a climate change context, we certainly try to follow it. More and more states are looking at adaptation plans, how they can try and make their community more resilient. You know, focused on North Carolina, we have so many extreme events anyway. A lot of what our climate adaptation plan is going to be for the future is really just making ourselves more resilient to a lot of the climate hazards that we faced already.
Okay, here's one from Leslie, and I actually had to look this up. She wants to know is, do you use the Milankovitch theory, which, and on Google here it says the theory describes the collective efforts of changes in Earth's movements upon its climate. Are you guys familiar with that, and do you use it in your work?
Well, I teach Milankovitch cycles to my freshmen, so they have an understanding of what's driven the large-scale dynamics in glacial and interglacial periods over the paleohistory of the Earth. So the Milankovitch cycles are the changes in the obliquity, the tilt of the Earth's axis, very small tilts. But these things happen on the order of 60,000 to 100,000 year intervals. The obliquity, the eccentricity of the Earth's cycle, orbit around the sun, actually shifts slightly, and so all of these are closely connected to the glacier and interglacial periods that have happened in the sort of the very long-term, million-plus year history that we have from ice cores and soil cores and the geological record of this. But on day-to-day basis, other than teaching my students, that's probably I use the term Milankovitch cycle probably twice a year in the 2 lectures that I teach my students. And that's it.
Thanks, Ryan. Here's a question from Thomas. He wants to know, in a typical week, how many hours do you normally work, and how does it break down as far as sitting in front of computers, doing field work, administrative duties, paperwork for supervisors, just kind of a breakdown on what your typical day is like.
Okay, that's a interesting question. I don't know if I've ever really thought about what a typical day is. It doesn't seem like there's ever a typical day. So I'm in a group where we have folks that's a pretty big group, so I probably do more administration than some of my counterparts do, because I have to. As you get a bigger group, you just get more bureaucracy. It's part of the travel. I spent a lot of time traveling this week already. I've given 2 talks out across the state, and I'll be going out again tomorrow to give a talk to a bunch of grain growers in the eastern part of the state. So a lot of what we do is going out and talking. That's sort of the extension side of things and the outreach side of things. We'll spend some time, I'll probably spend on any given month, maybe 1 day out in the field working on a weather station, because we have other technicians and scientists that work on that. A lot of my time is spent talking to students and other scientists that are focused on their specific projects, and I'm sort of bringing some different perspectives or different expertise to it. I spend a lot of time actually doing administrative email, not so much email just because of making sure people get paid or anything, but okay, what are the new projects that we're talking about? What are the partners that we need to be connecting people to? There's been a lot of activity on the federal side recently with climate hubs and big climate centers that are Interior and USDA is putting together. And so I've been involved in those here in Raleigh and trying to help coordinate those and connect those folks to the other networks that are involved in climate and climate applications. A lot of what I do is talk. In case you haven't guessed yet, I like to talk, and so I spend a lot of time talking to people either on the phone or through the computer or hopefully face-to-face, which is what I enjoy most. And of course, I love to talk over coffee and I love to talk over lunch, so I try to make sure that I have at least one of those every day.
Thanks. Here's an interesting question. John writes this. He says, weather-wise in every state or region, each state has its moments of extreme events, but among climatologists, who is considered to have the most exciting and most boring gigs out there? Is Florida the most exciting? Is North Dakota the most boring? What do you guys? How do you rank them?
You know, that's a good question. I don't know. I would say that in many ways, California has some of the most complex climate, and they can go. They get, you know, most of their precipitation falls in a handful of events. So when it rains in California, it really rains. But then they can have a drought followed by a catastrophic event. And so it's really interesting in Florida, but in California. But California doesn't get hurricanes. You occasionally will rarely see a tornado there, but they don't see those very often. So the Southeast gets all the severe weather, and so in some ways the Southeast gets it all, but they don't get a lot of the big blizzards. And so if you want a big blizzard, we get them occasionally, but they're pretty rare. Nolan, who do you think has the most interesting state out there?
Well, I'm just thinking of our typical meetings when we get together, and for those of you out there, when the state climatologists get together, we all just jabber about our climate, just endlessly, enthusiastically, and I would say every single person can get up and talk in front of an audience as if their state had the most interesting weather in the entire world. And I think all of us know the unique things. You know, Nevada you'd think would be a fairly dull, dry state with not that much going on. But the people that know Nevada know, for example, what is it known for? It's known for some of the largest day-night temperature cycles anywhere, where you can shoot up to 100 in the day and then drop down to 30 at night. And so every state has something to be climatologically proud of.
You know, that reminds me of, as I've traveled around the country, I've met different people, and they say, you know, we have a saying in our state, it's unique to our state, that if you don't like the weather, wait a minute and it'll change. And it's funny how many states actually say that about their state. So, yeah.
That's right. And everyone talks about how crazy the weather is in their state, and that's just because it is. I mean, unless you're in a desert where it's dry all the time, or you're in Antarctica where it's cold and snowy all the time, everyone gets to have variability. I think the only states that would be considered as having maybe less interesting weather are the very small ones, just because they don't have the geography to really have as much diversity. So Delaware, Rhode Island maybe has some of the least interesting, but they both still get impacted by big coastal storms and big even tropical storms. So anyone on the East Coast certainly has the tropical storm risk.
Okay, here's a question from Jim, and he wants to know, does NOAA employ many climatologists in their day-to-day operations?
NOAA does have a lot of climatologists. In fact, NOAA is the ones that support the National Weather Service's Climate Prediction Center, and they have a lot of research scientists that are out there. Many of them are in Boulder, Colorado. There's another big group in Asheville, North Carolina, that are climatologists looking at larger-scale climate dynamics, as well as sort of improving the seasonal and longer-term forecasting. NASA has a bunch of climatologists too. But among the group of applied climatologists, most of those are actually at the state agencies and in universities. More of the research climatologists are focused in the federal government, and as well as some university research climatologists that are out there.
Chuck from Indiana asks, he says, we set our record snowfall this year. What will our state climatologists look for in this data?
Well, speaking for Dr. Niyogi, my guess is one of the things he's looking for is, okay, how does this record really compare? How valid is it? If it's going to be truly the snowiest winter, what were some of the factors that led to that? Are there indications from that we can learn from to try and make ourselves more resilient into the future? So he's looking not just at the records and the extreme events, but also the atmospheric events that led to it, and then the impacts to it. So that if this event comes again, what can we do to be prepared for it? Is this truly a record event that we're never going to see again, or is this something that we do need to be prepared for again, maybe not next year, but maybe 10 years down the road?
Ted writes and wants to know, how do climatologists make use of CoCoRaHS data to improve their forecasts and models? Are the data good enough to support geostatistical analysis?
Well, one of the wonderful things about CoCoRaHS is the station density. So we actually have with CoCoRaHS a dense enough network that we can do geospatial statistics. So we don't have to just make the statements we used to make where, well, it's what it rained here, but we don't really know what happened down the road. Well, with CoCoRaHS, we not only know what happened here, but we know what happened down the road. And so it helps to really improve our understanding of the spatial variations of rainfall, and we can do things like then overlay that and calibrate some of the radar products that we have that give us another set of spatial measurements.
I might add, we have found in areas where we have lots of stations within a relatively close area, surrounding stations where we have long-term weather records. For example, here in Fort Collins, our weather station has collected complete precipitation data for 125 years. And what we found was taking about 30 to 40 stations within 10 miles of our historic station, we were able to, in just 3 years, quantify very well the frequency of precipitation events, like the number of events between 1/100th and 1/10 of an inch, between 1/10 and 1/4, all the way out to near the end of the tail of the distribution. In just 3 years, we were able to define that shape of that precipitation event frequency distribution. Now, the extreme tail, the all-time records, the 100-year return period kind of things, we're less confident that we can do that with the short record. But just one of the advantages of having many stations. Furthermore, historically, it's been very hard to quality control data, and as Brian referred to, there are issues, for example, with snowfall measurements in the southern states where observers have just not been that well trained and experienced in observing it. So the historic records are not all that confident. But when you have many, many observers giving it their best shot, you're much more able to identify the good data from the questionable observations.
You know, here's another related question. Alex in California writes, and how does CoCoRaHS data gathered from all of us compare to nearby sensors? So do you use all the data equally, or is there a leaning towards your sensors over the CoCoRaHS data?
Well, Nolan might be able to answer this better than I, because he's done a lot of the studies with it. But from what I've read and from our own very small studies, CoCoRaHS data compared very favorably with the automated gauges. In fact, with the human measured gauges, they compare very well. They actually do better than some of the automated sensors out there that have a hard time keeping up during very heavy rainfall. So with some of the automated tipping buck gauges, as well as some of even the weighing buck gauges that are out there that are automated, where there's not a human person there, they tend to undercatch the actual rainfall. They just can't keep up with the very heavy rainfall rates that certainly we and other states get. And so the CoCoRaHS gauges actually tend to be more accurate in those situations over a 24-hour period. So we rely on that. And one of the things, of course, CoCoRaHS doesn't have that we rely on some of the other official gauges for is that very long-term record. But what CoCoRaHS allows us to do is to look at how it changes over space and time as just as well in some cases, in many cases over space, a lot better than we can with the official records. But it helps us to still put what happened in any given event in terms of that longer-term historical context in the absence of another long-term record.
And the measurement of the water content of snow is something that no gauge has been that good at doing, other than the manual gauges managed and maintained by the National Weather Service Cooperative Network and CoCoRaHS. So there are many times that users of the data wish that our data were being updated every 5 minutes with perfect accuracy, but they know the niche that we're filling is the high-quality daily reports to confirm what happened, and again, they are viewed interchangeably as good a quality as the National Weather Service's Cooperative Observer Network, which is our 124-year benchmark observing network for the country.
The thing that's really interesting with CoCoRaHS data is in complex terrain like the Rockies or in the Appalachians here in North Carolina, it really gives us a better sense as to what the role of mountains are in rainfall. From one ridge to the next, we can see dramatic differences in rainfall. Now, we've always theorized, but now with CoCoRaHS, we can actually quantify. The other thing is in a coastal community, especially in the southeast where we have sea breeze events, we've always theorized that the rainfall right along at the beach is probably lower than it is further inland, because as the sea breeze moves inland, you get convection associated with it, you can get thunderstorm activity. Well, with CoCoRaHS, we can actually quantify that now because we have the rain gauge density that we need to see that, yes, the gauge right on the beach is actually not measuring as much as the one further inland.
So when you hear me, so when you hear me getting excited about those gaps on the map, it's really not that easy to interpret, interpolate, estimate unless you have a very high density of observations. We're able to combine our gauge measurements with other networks and then relate them to radar estimates that try to fill in those gaps, but it takes the ground truthing to make those radar estimates high value.
Here's Chuck from Oregon, and Chuck says, wants to know, does La Nina and El Nino affect more than just the West Coast? So is it just Oregon and California that get affected, or what about the rest of the country?
It certainly affects the rest of the country. In the southeast and in the Ohio River Valley, we have very strong relationship to El Nino. So when we have an El Nino event, our winters tend to be quite a bit wetter in the southeast, especially along the Gulf Coast and along the eastern seaboard. And when we have El Nino events, the Ohio River Valley tends to be quite a bit drier. It actually deflects the jet stream. It amplifies the jet stream more. We get more storms that dip down into the Gulf Coast states. We get more storms that track on the eastern side of the Appalachians. When you have La Nina, we see the opposite. We actually see drier conditions in the wintertime along the Gulf Coast and the eastern seaboard, and we see wetter conditions in the Ohio River Valley. So it's a pretty strong statistical relationship, but with what happens with El Nino and La Nina and the weather patterns we have, especially in the wintertime.
Here's John Wright. Oh, go ahead.
I was just going to say sometimes the correlations are stronger in the southeast than they are in the west. People don't all appreciate that.
Here's John right down the road in Fayetteville, North Carolina, and he wants to know, speaking of automated sensors, what's the effect of new automated sensors on the climate record?
That's probably John White there at Fort Bragg. So the introduction of automated sensors has been a bit of a controversy, and in hindsight, we would really have liked Weather Service to have overlapped their deployment of some of the automated probes that they had deployed in the mid-90s at the major airports, have overlapped that with the traditional sensors so that we could understand what those relationships are and how they would transfer. For the most part, the sensors give us the type of reliability that we need, but we know that there are some issues with the new shelters that are used and how those have a relationship to the historical record. We know that the new automated rainfall gauges that are used tend to not capture heavy rainfall as well as manual gauges. To the extent that it's been possible and you can have co-located sensors for a period, we've been able to sort of identify what the statistical relationships are and develop transfer functions so that we can relate one probe to the next.
And so far, technology hasn't helped us to come up with an automated approach to consistent measurements of snowfall and its water content. So it's a challenge that continues.
So yeah, if there are any listeners out there who are budding engineers or scientists, you could make a lot of money real quick if you could come up with a low-power, truly all-season precipitation sensor. Every government in the world would buy it from you.
And every engineer who has not worked with that problem before assumes that there's just never been a smart engineer look at it. And in reality, it is a tough nut to crack.
Okay, Lance from Washington State was wondering, does geoengineering make it harder to interpret and predict the climate?
So geoengineering is this idea of of trying to modify the atmospheric system by putting up sulfates or other things to cool it or otherwise warm it. We've done a little bit of we've seen a little bit of that in terms of rainfall enhancement due to cloud seeding and snowfall enhancement due to cloud seeding. Not so much in the eastern U.S., but in some states out west they've done this. There is mixed studies as to whether or not they're effective, and therefore mixed as to whether or not we are really seeing if we can quantify the human impact and change in the climate system from that type of geoengineering. Most of the science right now is looking at what it means in terms of longer-term climate change potential. But Nolan, I don't know. I mean, I know most of the seeding projects have been out west. Has there been any studies to show what that anthropogenic effect has been on the precipitation patterns in the western U.S.?
Cloud seeding research continues to go on. In fact, the state of Wyoming has paid millions over the last few years to try to document, quote unquote, once and for all, the effectiveness of cloud seeding on enhancing winter precipitation in the West. And it's also been a statistical challenge because there is so much natural variability that it's very tough to pick out the signals of the geoengineering, the cloud seeding activities that have gone on. The long-term conclusion has been that you can enhance precipitation from certain winter snowfall events, maybe 15 to 20%, but over the course of a winter as a whole, not all cloud precipitation events are as quote-unquote seedable as others in terms of the effects. So that cloud seeding is certainly one of the most practiced methods and has been done for literally 60 years in parts of from the Sierra eastward to the Rocky Mountains. But east of there, a bit different ball game.
Natalie wants to know what are they seeded with? Is it iron? What's used to seed the clouds?
The material that has been viewed as most effective has been silver iodide, which is a compound that when flamed, there's a variety of ways of injecting it. It breaks into crystals that look exactly like, totally mimic the small nuclei of precipitation particles, and water vapor will glom onto those little crystals and rime onto them, making growth of the crystals, just like the regular snow formation process, but with more nuclei present to do that. So it's mimicking the actual precipitation nuclei, but with an artificial material. And people then get all really bent out of shape about, what do you mean, heavy metal silver injection into the clouds? It turns out it's very, 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 very small concentrations. Usually can be detected by high-level chemical analysis, but at very low concentrations. So it's usually not an environmental hazard.
Okay, we've got two questions on global warming, one from Paul in Boone, North Carolina, another from Tom. And this one would probably take a long time to go through, but please explain global warming, both short-term and long-term, and its causes. And then the question from Tom is, do you feel that the global climatology community has done a good job of communicating to the populace, leaders and politicians, its views on global warming, and what are the challenges of gaining acceptance to those views? So if you could quickly describe what the global warming is, how climatologists have done in communicating this, and what challenges in communicating these views.
Right, so global warming is sort of the average increase in the global average temperature that's been observed over the past 150 years and what's expected to increase due to a combination of factors, but to a large extent the increase in greenhouse gases in the atmosphere. We're changing the chemistry of the atmosphere, and it changes the radiative forcing, how much energy basically gets trapped in the atmosphere and trapped at the land surface to be able to change over time. And that has implications for local climate as well. But we sort of differentiate what's happening with global warming versus the local climate changes that may occur. For example, local climate has a lot to do with changes in land surface, whether we have cities that grow, changes in agricultural practices and forest practices. So, for example, in the southeastern United States, we haven't seen a lot of warming over the past 100, 150 years. In fact, in many cases in the southeast, it's actually cooled a little bit, probably largely due to the reforestation of the southeast. 100 years ago in the southeast, we didn't have nearly the tree coverage that we have now, and that reforestation has probably led to a net cooling effect. There are other factors. They think sulfate aerosols coming out of power plants probably played a role, but the broad science is, as we put greenhouse gases into the atmosphere, they have an impact on the radiative forcing and actually trap more heat in the atmosphere, and then that will then balance out through responses and changes in weather patterns on months and seasons, etc. And I'm not my expertise is not in this research area, but I can say that I think there's been a lot of successes in communicating the science of climatology and global climate patterns, global change, to other scientists. We haven't done a very good job in conveying the science to folks that make policies. And there's actually an argument in our field right now as to whether or not that's our role. There are some that feel very strongly that scientists should be very active with the politics and the policy and really get out there and promote that. And there are other scientists that say, well, no, policy is driven on more than just science. Policy is driven on a lot of decisions that have to do with society and justice and economics, and that science is just one of the aspects that should go into that. And so you could probably argue that, yes, scientists could do probably a much better job of talking about the science to the policy folks. But I think the scientists that are out there that are promoting and really discussing this, they've done a pretty good job of putting it together. We have an international effort, a report that comes out fairly frequently from the Intergovernmental Panel on Climate Change. All of that stuff is in there. I think the reason why it's controversial is because folks, it's not that they don't understand the science or don't want to understand the science. I think it has more to do with okay, so what do we do about it, if anything? And then sometimes there are perceptions of winners and losers, and that's when it really does get into the policy questions that really science by itself can't answer. That's my personal view.
And one of our viewers today was asking, Brian, how do you see the difference between the science subject matter expert advisor role versus the policy advisor role? So,
right, and so there's a role, and I think an important role for scientists to be out there talking about not only what the science is saying and where it's pointing us, but also how science is done, so that we as a society sort of understand more about the process of science. But policy advisors are there. Hopefully they listen to the science advisors, but policy advisors have to weigh a lot of different factors, including short-term and long-term economics, issues of social justice, what is considered fair to the broadest number of people. It's a lot of it gets much more complicated, and that's why for policy you need to have some influence from not just the physical scientists, but from social scientists and economists and folks who think about broader impacts beyond what the scientists by themselves can say. I mean, I could probably stand here and say, well, if everyone would just listen to the scientists, we'd have solved all of our problems by now. But obviously, that's not true.
Thanks for illuminating us on that. Here's a firefighter in California, professional firefighter, and he says that they have that extra season out there called wildland fire season. They've come to rely on climate data and long-term forecasting to predict how their fire season will be compared to previous fire seasons. They use this data to hire more people in a bad season. How accurate, he wants to know, is the forecast for the climate 3 to 6 months in advance?
Well, I'm not as familiar with the California climate. I do know that they have also a fairly good relationship with what's happening with El Nino and La Nina. But a lot of what happens also in California, I know, is driven on the water supply from the previous winter. So there's a lot of attention right now with California and the drought in California and the lack of snowpack, even though they've had a good storm here recently, that the water availability that's there is largely driven by what happens in the cold season, because they don't get a whole lot of rain during the warm season. But in that fire season, a lot of it depends on whether or not there is a good, meaningful forecast for what's happening in the Pacific Ocean. And if we understand and have a good, strong forecast, a high confident forecast for what's happening in the Pacific Ocean, that really increases the confidence that we have in the forecast for California. So if you have a strong El Nino event, that really kicks the statistics up and gives you much more confidence in your forecast for the season. If you have a really strong La Nina event, you really have more confidence in the season. So there are other factors that come into play, but really what's happening in the oceans and our ability to predict the oceans on 3 to 6 month time scales is what leads to some confidence in those forecasts. But in the absence of a strong El Nino or a strong La Nina, there's not as much confidence in what's going to happen, and therefore the forecasts for 3 to 6 months are not as good.
And here in Colorado, we have found this 3 to 6 month seasonal forecast is we have a lot to base it on, about 2 years in every 10. We have something to base it on, another 2 to 3 years in any 10, and about 5 in 10 years we have very little to base it on. And so you're not going to get a red-hot, sharp forecast every season by any means.
Okay, John writes and wants to know that you guys aren't forecasters, but are there online forecasts that are typically available to the public from state climatologists, and what would those be?
A lot of the state climatologists will put out a seasonal forecast for their state, or take the national forecast and try to translate that into something for their state. So those are often put out. We'll put out we put out our winter forecast. We'll put out a spring forecast here probably. Well, the official CPC forecast I think came out today, so we'll probably work on a spring forecast next week. Short-term forecasts are sometimes also available from some state climate offices. My group does some experimental forecasting for agricultural diseases, and so we actually have routine models that are the short-term forecasts that are put out 4 times a day for the next 3 to 5 days, mostly focused on dispersion modeling for smoke and agricultural pests. But for the most part, you can go to the state climate office for your state, and they'll link you to the short-term weather forecast from Weather Service or someone else, but they aren't the ones that are putting those forecasts together themselves.
And we've put some links on our website, the AASC, the American Association of State Climatologists. You can click on there. That'll link you to all the state climate offices around the country. That's on the CoCoRaHS Weather Talk webinar site under Ryan's talk. You'll see that listed there. There's also some other links on there as well. A couple other questions. We're at the top of the hour now. We'll take a few more here. Here's one here that basically for North Carolina is beach erosion still a problem along the coast of North Carolina? How do you guys deal with that?
Beach erosion is a problem for a lot of communities. We have current-based, so the ocean currents will actually erode the islands, in particular the barrier islands. They'll pull off sand on one side and deposit it on the other, so the islands actually migrate. Of course, that makes it tough if you have things like a road. But we also have erosion from coastal storms in the wintertime and, of course, tropical storms. And that is a big deal. And tropical storms are some of the ones that are very famous, that come through and create new inlets and wash out entire highways that then DOT has to come back and re-engineer. But we also actually have a lot of erosion that comes from coastal storms in the wintertime. In fact, we can have overwash events. There's some famous ones there in Rodanthe on the Outer Banks, where there's a house from a recent movie, I think Knights of Rodanthe. I think it was a movie that the ladies liked. I never saw it. But we'll have overwash events where the ocean is overwashing the entire highway, that entire barrier island, even when it's blue sky outside, because there's a coastal storm that's sitting far enough offshore and just sending tremendous wind, tremendous wave action, and actually pushes the water up over the island in those areas where it's really narrow anyway. So that beach erosion is a perennial issue in North Carolina. It hasn't gone away. It will never go away.
And a few years back, I remember Cape Hatteras, the lighthouse, had to be moved. Is that right? Because they moved it back?
That's right. We right now do not allow hardening the shoreline, and that's another policy decision that was made. There's science to suggest that it doesn't do any good to harden the shoreline, but of course people who have property there don't they would really like to be able to put cement in its place. But they moved the lighthouse because it was so close to the water's edge that it was at risk of falling into the ocean. And it was, it's the tallest lighthouse on the East Coast. And so they moved it. They actually engineered and moved it quite a bit further inland to move it out of harm's way, so that it can continue to be that cultural resource.
Okay, here's our last question of the day, and this would be good for Nolan as well, and anybody with CoCoRaHS experience out there. The person writes in, there's a lot of gaps in the maps, as you mentioned. What is the best way to evangelize nearby counties with no gauges? So you'll see a concentration, and then there's nobody there. He says, should we look at grade school teachers, and get their parents to? What are your thoughts on this, guys?
I probably am not the expert here. In fact, I know I'm not. I'm sure there are lots and lots of ideas that will probably work for different communities. It probably is a diversity of ideas. There's no single magic bullet, or else everyone would be doing that. But I can say some of the things that have been successful in North Carolina is reaching out to community newspapers, the smaller ones sometimes that are free, and trying to promote them in those. Often it's going to church meetings where people who are interested in talking about those things and are casual, but that's a community central gathering point for some of the smaller, more rural counties. The other thing that has somewhat worked well for us is we've been pretty successful in getting some schools to adopt CoCoRaHS and use it at the school, and we actually try to donate a gauge to them if they go through the training and sign up. But one of the problems, of course, with schools is then you don't get observations often on the weekends, but the kids get really excited, and maybe the kids can then go home and get a rain gauge at their house as well.
One of the most impressive rural recruiting efforts that we've seen has taken place in Nebraska over the years, and they had the benefit of regional staff who were asked to help with CoCoRaHS as a part of their jobs, their natural resource districts in Nebraska, and they literally knew the landowners of their respective counties and specifically asked landowners saying, you're in this area, we really need your data. And they had the credibility, and they backed it up by doing something that most of us don't have the luxury of doing, and that was they were able to give each of them a complimentary rain gauge if they were willing to respond. And that's something we just don't have the resources to do on a national level. We've also found that in some counties there are extension agents associated with the land-grant university that have been great advocates, and most counties of the country are covered by something that some of you may know well and many of you may not know at all, and that's what used to be soil conservation districts, which were then later named either conservation districts or soil and water conservation districts. And they're composed of landowner boards who, again, know the connection between climate and agriculture and the resources of the land. And we've had, again, some success there, but we have found no perfect, what you'd call the silver bullet, that works equally well everywhere. And I appreciate you asking that question because it's on all of our minds.
Hey, we had one more question sneak in there. I'm going to ask it of you guys. If you could, the request is if you could explain what katabatic winds are and how they create rain shadows.
Both of our states have them.
We do, yes. Much more common in Colorado than in North Carolina.
But a katabatic wind is a wind that warms by compression as it descends in altitude, and the very warming that is simply physics. The air, as it drops, has more air pushing down on it above. It's very much the same as the reverse process of, well, I guess it is the compressor unit in an air conditioner, both compressing the air and then expanding it, and that causes gravity-driven winds and pressurized warming. It's a very basic physics concept, and yet it ends up being surprisingly hard to explain without drawing things on a board and showing some pictures.
Yeah, so as wind goes up a mountain and it has moisture in it, a lot of that moisture will fall out as the air cools, and so you get on the windward side of a mountain or a mountain ridge, you tend to get increased rainfall. And then on the backward side, as the air descends back down the mountain, it heats, it dries, the humidity drops in it, and therefore you don't get as much moisture, and that's what can lead to a rain shadow on the leeward side of a mountain.
Well, gentlemen, thank you so much for answering these questions today. Ryan, taking time out of your day to be here with us. We really appreciate that. And we'll have this broadcast recorded and up on our website later this week. Well, folks, please join us for our next CoCoRaHS Weather Talk webinar. That's coming up, in just about a month, the end of March on the 27th. That's a Thursday, where Dahlia Kirschbaum of NASA's Goddard Space Flight Center will talk about how NASA studies Earth's weather, climate, and hydrology from space. That's one you won't want to miss. Finally, before we leave today, please take the survey at the end of today's webinar. If you would do that, we'd really appreciate it. Again, on behalf of the CoCoRaHS staff here, we thank you for being with us today, and have a good week ahead. Goodbye now.